All right, here we're looking at Chapter 1, Section 1 in our pre-calculus book. So the big thing I want to look at during this section is our learning targets, which are right here under objectives. First, we're going to be using the distance formula, and then we're going to be using the midpoint formula. So these need to absolutely go in your notes and make sure that our focus is on these two learning targets for today. So when we're looking at these two things, and really a lot of the stuff that we're going to work on this year deals with our XY coordinate plane. And you've seen this a lot before. This is also called our Cartesian plane. So when we're plotting points, remember it's always our X value, then our Y value. So X, comma, Y. And X is always, of course, going across, and then Y is up and down. So here this point 3, 2 has been plotted, and I go the positive direction 3, and then I go up 2. That's how I get this point. So we have 4 quadrants that we're going to really be looking at. So this is quadrant 1. We always start here, and then we go counterclockwise when we count our quadrants. These will come in handy a lot later, so just kind of get used to understanding which quadrant points fall in. Often we're going to be using our graphing calculators or Desmos, and this is just kind of our standard viewing rectangle. You can change this at any time, and we'll go through some of these things in class as well. So here we go. Our first example for our first learning target was using the distance formula. So the distance formula is used when we're trying to find the distance between 2 points on that Cartesian plane. So here we're going to be finding the distance between 1, 3 and 5, 6. Those are our 2 points that we were given. So the first thing we always want to do is kind of just draw a little graph and plot those points. So I see I've already done that here, and I've connected them with this line segment D. So before we actually get into the distance formula, there's an easier way to do this. I can just turn this into a right triangle. As you see over here, just connect both sides, and so I see I have a right triangle with one leg being the length of 3 and one leg being length of 4, and the hypotenuse being this length of D. So I can use my Pythagorean theorem, which of course is my a squared plus b squared equals c squared. So let's go ahead and use that here with my a and b being the legs. So I know one leg is 3, one leg is 4, and the hypotenuse was D. So 3 squared is 9, 4 squared is 16, equals D squared. Well, 9 plus 16 is 25. And then I take the square root of both sides to get D by itself. So I see here that D equals 5. So I now know the distance between these 2 points is 5. So now here's the actual distance formula. It's the exact same thing we just did, only using slightly a different order. Okay, so the distance between 2 points, point 1 and point 2, these, when we have a number that's down below our letters or numbers, that just denotes which one. So this is telling me the first point, so this is telling me the x of that first point and the y of the first point, then the second point, so the x of the second point and the y of the second point. So here is my distance formula. So I take x2 minus x1, the distance between the x's, and I square it, plus the distance between the y points, and I square it, and then I add those together and then take the square root of the whole thing. This right here is the actual distance formula that we're going to be using. So now let's look at a little proof of this. It's not super important that you understand every step of this, just kind of follow along here. So here I've plotted my 2 points, right? I've got P1 and I've got P2. Well, from what we did earlier when we made that right triangle, I also have a P3, okay, that has the x value of my point 2, but the y value of my point 1. So now I have all of the points I need. So I see that this leg length, right, and when we're talking length, we're always talking absolute value because we cannot have a negative length. So I have the absolute value of x2 minus x1. Here, for this leg, I have the absolute value of y2 minus y1. Okay, so now I can see that that's where I get some of that information from. Okay, so now still looking at this same proof is again, we're just looking at distances, so we always will have this absolute value. Okay, so now we're going to actually just use the distance formula. So we can find the distance between these 2 points either by using the distance formula or by drawing a triangle and finding the lengths there. But for this example, we're going to go ahead and use the distance formula, right? So here I know I have an x1, y1, and I have an x2, y2. So let's just look back at what the actual distance formula is, right? So I know the distance formula is the square root of, I've got my x2 minus x1 squared plus y2 minus y1 squared. So now that I have this written down, now I can go ahead and plug in the information that I'm given from my 2 points, and here's what I end up with. So always make sure that when we have negative point values that those go in parentheses, so then we can kind of simplify from there. So 3 minus a negative 4 would be 7, and 2 minus 5 is negative 3. I square both of those values, and I add them together and find the square root. So I find that the distance between those 2 points is either the square root of 58 or it's approximately 7.62. Sometimes you will be asked for the exact distance, which is what you'll give here. If it says approximate, that's what we will do right here. Either one, depending on what you are asked. Okay, so now we're going to be using some algebra to solve some geometry problems. So here I have 3 points. I have point A, which is at a negative 2, 1. I have B, which is at 2, 3, and I have C, which is at 3, 1. So first I want to plot each point that makes this triangle. Then I have to find the length of each side and then show that it's a right triangle. Then I want to find the area of the triangle. So this one has several parts that we're going to be working through. So here let's figure out part A. Asked us to plot those points and show that it's a triangle, which has been done right here. So I see I've plotted point A at a negative 2, 1. Point B was at 2, 3, and C was at 3, 1. So now I can just go ahead and connect those points. So now I have to find the length of each side. I want to use the distance formula for each segment. So you'll see first I'm finding the distance between A and B, right? So here's the distance between A and B, so I use those 2 points. Here I'm using the distance between B and C, which is right here. So I will use those 2 points, and then D, I'm going to find the distance between A and C, which is right here. So I will use these 2 points. Okay, and all of this has been done up here. So I see that my distance from A to B is 2 times the square root of 5. And I just do that by plugging in those points into the distance formula. And remember, if I really want to, I can actually turn this into a right triangle and find the lengths of these legs and use my Pythagorean theorem. Either way will get me the same result. So I see that my length from B to C is the square root of 5, and A to C is 5. And so this was all just done using the distance formula, but with all of my different points. And you'll see here they wrote it out very nice and clean. So I have the distance from A to C. So I know exactly which length I'm talking about when I'm looking at my data. So now I have to determine, is this a right triangle? Okay, so if the sum of the squares of the lengths of the 2 sides equals the square of the length of the 3rd side, then it's a right triangle. So what this is really saying is if I take the first leg and I square it, and I add it to the second leg and I square it, does it equal the square of that 3rd one, what we would think of as the hypotenuse? If it ends up being equal here, then yes, I have a right triangle. If it's not equal, then I do not have a right triangle. So this would be not right triangle. But if it's equals, it is a right triangle. So we're going to use the results that we got in our previous part. So I'm going to take my distance from A to B and my distance from B to C and square both of those and see if that equals the square of my distance from A to C. And you'll see here that it does. So because this is equal and it does work out, then I would say yes, this is a right triangle. Okay, so now I was asked to find the area of this triangle. So I know to find the area of a triangle, I take 1/2 times the base times the height. So I have here 1/2 times my base times my height, which gives me 5 square units. Now remember, my base and my height are always at right angles to each other, so that's why it can be very useful to figure out if this is a right triangle before we go any further, because then I already have all the information I need to find the area of that triangle. Okay, so that was our first learning target, using the distance formula. We used it both with pictures, and then once we actually found the formula, we used it that way as well. So now here's our second learning target, using the midpoint formula. Okay, so the midpoint formula tells me I can find the point that's exactly halfway between my two endpoints. Okay, we're going to get to the formula, but there's another way to do it too. That sometimes drawing pictures is easier. I know it is for me. So here I would see I have point 1 and point 2, and I want to find the midpoint. So I always plot my points and I draw my right triangle. Okay, so I see here that I have this length, this distance, right? So I know that the midpoint will be exactly half of this distance. So if I can find the distance, and remember this is our x, the distance from x1 to x2, and I would cut it in half. So I know that my midpoint would lie along that line. I can do the same thing with my y's, and I know that the midpoint will fall halfway between those two. So that can be helpful as well. Just drawing out my picture and seeing, oh, well, this distance is 4, so that tells me that the midpoint will be 2 away from both of the endpoints. That can be useful. Okay, so here's our actual midpoint formula. And this is exactly what we were doing, but sometimes for me a picture is just easier. So I take x1 plus x2 and divide it by 2. And then I have y1 plus y2 divided by 2. And that's how we can find the midpoint of any segment. One thing you can always keep in mind too is sometimes you'll be given the midpoint and be asked to find one of the endpoints. We can use this same information to get that as well. So let's look at an example here. So here we're going to be finding the midpoint of a line segment. So here I have segment with point 1 at -5, 5 and point 2 at 3, 1, and then plot them and their midpoint. So first I generally always just plot my points, right? And this does not always have to be super pretty. So I know it's going to be a -5, 5. Oop, there's 1 point. And my second point was at 3, 1. Okay, so there's my second point. So now I have to find the midpoint. So I can either use the midpoint formula that I've looked at before, or we can do it the other way. So let's do it this way first. So my x distance here, so I see to go from -5 to 3 is a distance of 8, right? And I can do that just by counting. So I know that my midpoint will be 4 away from each, so it will be right here at a -1. Okay, so now let's look at my y values. I notice that my y values to get from 1 to 5 is 4. And again, I can just count and see the distance here. So I know that my midpoint will be 2 away, which will be at 3. So now I know my midpoint is a -1, 3. So now let's look at actually using the midpoint formula to find that information as well. So here we go. Here's the midpoint formula using those same points and those same pieces of information. So I see I take x1 plus x2 divided by 2, which is that -5 plus 3 divided by 2, which is -1. And here's my y's. y1 plus y2 divided by 2 gives me a 3. So I end up with the same exact midpoint, and my picture looks pretty similar. It's not as pretty, but it actually looks pretty similar. Okay, so let's do a quick review on what our learning targets were. First, we had to use the distance formula, which we were able to do either using pictures, which is the Pythagorean theorem, or actually using the formula. And now here we were using the midpoint formula, again, using pictures and finding the distances between the 2 points, or actually using the formula. So here is our section 1.1.